So next up, now that we have learned about how to actually create a table, change the table, stuff data in a table, remove it again, and generally fuck it up in different ways that are very horrible and can break an entire production system, totally not from personal experience, we're going to be talking a bit more how to actually model the data. I know you haven't actually read this, so I'll try to explain a lot of it, and then I hope the video playlist on Linda will help you actually get the last understanding. In my opinion, it usually helps hearing something multiple times. The first thing we're going to be talking about is basically choosing your primary key. So remember when we did create a table, students, then we did id int auto increments. Why does it not like this?
Because it's a C increment, not increment.
Oh, yeah. And then we set primary key. So what does primary key mean? Well, primary key basically says that this is the thing that identifies this row. So in this case it's our ID, but we could also have done, for example, like the name as a text, and that would be the primary key rather than the ID. It wouldn't make much sense because it kind of changes all the time. Oh well, occasionally at least. For example, when people get married, they usually take, or some people take their spouse's last name. So then you would have to update it, so it wouldn't be a good primary key.
But also the primary key has to be unique.
Yes.
And there's a potential that names could be the same.
Yeah. I actually don't think it's required for them to be unique. At least not in all systems. It makes the most sense, but I actually don't think it's necessarily required.
To be unique?
Yes. It probably is in a lot of systems, and you'll probably
then
have...
it wouldn't make sense to have auto increment.
No, auto increment just helps you having it.
Because it helps to have a unique ID.
Yes, but that's just so you can select each individual row.
Yeah.
And like I can't see why it would make sense not to have it, but I don't think all systems actually requires it to be unique. Most do, however. So like some system doesn't require a primary key at all. For example, NoSQL databases. What we can also do with this is say that, all right, we have actually both. Let's just make it a varchar 100, because then I know the index will actually work. We can say that, all right, we actually have what is called a composite primary key. So we can have a primary key that's a combination of both the ID and the name. So only if we have both the ID and name can we uniquely identify a single row. Which again goes back to that whole, does things need to be unique? Yeah, for things to work the best, they do. So that's basically primary key. So how do you choose it? As mentioned, create an ID column on an ID column on basically everything. Basically, when we're looking at many-to-many relationships, that is the one case of where we don't want an ID column, but basically you always just want it and then specify it as primary key. It just makes your life easier, and it makes it consistent with what most other people do in the world. Yes?
For example, when you have a database like for citizens of Denmark, when you have the CBR,
yes.
Do you need to specify ID also, or is enough that you specify the CBR and you make it the primary key?
So some people would argue that the CPR is enough, but I actually think there is a clause that allows you to get a new one. For example, when you immigrated to the country, you didn't have a CPR, so you got a new one.
Yeah.
But I also think it can be changed if you go into witness protection. That's at least in some countries, they allow you to change it. But if you go to countries like Germany, they don't have a CPR. What uniquely identifies you is a combination of your name and where the fuck you live.
What?
So, yes. So if you move around, like that was what my German database teacher told me at least. So I assume he's correct. So if you move or change your name, what uniquely identifies you changes. So it basically means they have a primary key that looks like this: name, address, city, country, and a bunch more.
What is that? Chameleon country down there?
No, it's just German.
Yeah, they are weird.
Yeah.
I hope we don't record that.
Question.
Yes.
What's the max limit for varchar?
I think you'll have to look that up in the documentation.
Because all the examples of
'Cause there-
varchar I've seen it is 255.
So,
65.
according to what it says here, this much.
65,000.
Yeah. So basically,
What was it say there?
16 bits.
Varchar columns are variable length strings. The length can be specified as a value from 0 to 255 before MySQL 5 and 0 to 65. Oh, okay. So
Yes.
they changed it.
Yeah.
So that's why all the varchar that I looked at as an example,
Yeah.
not recently, it was 255.
And basically,
That's
I tell you to use text because it'll work correctly for what you need. And I think the limit of text is like really, really huge.
Another question. What would be the data type for pictures? I mean,
Bl-
I know it's not ideal to
Blob,
The blob.
which just means binary large object.
Binary large object.
So a blob.
But it's not really smart to.
No, don't. I wouldn't recommend putting files in your database. You can, but I wouldn't recommend it.
It just blow up. Not blow up. So like, how do you say that?
Yeah, it blows up. It increases in the size it needs very, very quickly. Also because, like, for example, like lots of things you can want to do with data is like index and search in them, and you can't really do that with binary data. Like you would need some other way of storing the thing you're looking for. So what some systems do is they basically just take a hash of the image that might be 32 bytes, and then that's what they save, and then they save the actual image on disk onto that name of, and like they say, the name of the file will be the hash of the file, so they can quickly look it up on disk and then find it. And that's what most systems do. Like storing blobs in your database is basically only done in education scenarios. Like I have never heard anyone actually do it in a serious system, because as you say, it just blows up in size right away.
Yeah.
And it also makes the query, like your insert queries, really, really slow, because you need to verify that everything has been saved and such, and it takes a long time to transfer, and it's just easier not to do it. So any more questions about primary keys until we go and talk about relations? So next thing is relations and relationships. Yeah, it's gonna be fun. So there are three kind of relationships we can imagine. We have one-to-many, one-to-one, and many-to-many. So the names basically says it all. One-to-many means that you have one row that refers to many rows. So for example, in a class here at Hack Your Future, we have many students. So we might have a row that describes the class, that it's in Odense and that it's from this to this period. And then we have, for each student, it says that, well, this student is in this class. So then we have many students to one class. Then we have another class in Copenhagen that also has many students, but it's separate. So that's a relation between those two. Then we have a one-to-one, which is basically one row refers to another row. I would say that the usage of this one is actually quite rare, because usually when you have these, it's just as easy to just put them in the same one big row. That's not to say it doesn't happen, but like in my opinion, the use cases for it are kind of rare.
Addresses. Let's say if you have Would you have one, let's say, a table with the countries and a table with states? That would be a use for one-to-one.
Like what you might have is you have because then like in each country you have multiple states.
Yeah.
So then it's one to many. Because you have one country with many states, and many basically means more than one. They're very, very generous with what many means. But a good example of address might be like for an order, there's a shipping address, and they might store the address in a different table, but they could just as well have stored it with the order.
Yeah.
So it depends on how you want to model your data. For things like that, I would actually recommend splitting it out in two. What some people then do is that they, rather than saying that the order has an address, they actually say that the order has a person, but then it's a one-to-many because the person can have many orders, and then that person has an address. But that person might also have multiple addresses because they might have moved around.
Yeah.
So, like, for most of these, it's just more often than not smarter to specify them as a one-to-many. Because what you'll be doing in the database level is basically the same thing. The only thing is that with one-to-one, they have a key to the other thing, both of them.
Mm-hmm.
With one-to-many, only one of them has a key to the other. We'll be looking at how to model them once we talk about what they are.
Question.
Yes?
Before we get to many to many. Can you redefine, let's say after you build a database and there's some users in there and all that, can you redefine a relationship after they are done?
You can alter the table, and then depending on what you need to go to, you might need to tell it to copy and move some data around. It's not the thing is that we don't actually tell MySQL that this is a one-to-many relation. We call it that based on how we actually model the relation in the database. So which tables do we create?
Yeah. So table A and table B has a foreign key that's related to table A. And table B can also have a foreign key to relate to table C.
Yeah.
And so forth.
Yes, but it's not really formal in that the database will know that this is a one-to-many. It basically just says this thing points to that thing over there.
Yeah.
Okay, that's all it cares about.
It's how we see the data when we module. That's how you see how they are related to each other.
And what sometimes goes wrong is, should you use a one-to-one, or one-to-many, or a many-to-many? And it's basically one of those things where you really need to know your domain very well. And I mean, the worst thing that happens is you get it wrong, and then you need to do some code to move it to the other one. But I would say going from this to this is easier than the other way around. Because if you're going from many to many to a one-to-many, then you need to remove some data.
Yeah.
But which data?
Yeah.
Unless you're lucky that you actually happened to just not ever do an actual many-to-many data, then you need to figure out what data to remove. And that can be pretty difficult, but that's mostly up to, again, you as a domain expert need to know, well, which one of these is the actual correct one. What's more common is that you go from one to many to many to many.
That would probably be, we will probably have some indications on the project scope.
I mean,
let's say,
don't you define the project yourself?
Oh, yes, but I'm saying when you're going to work for someplace, and then you have to do that.
No, like your stakeholders won't know this shit. You need, as a developer, need to know. Basically, they say that for this order, we want to be able to store the products the user ordered.
Okay.
And then you need to figure out that actually means that there are multiple products. But you probably don't want to point directly to the products because you want to save it with the price it was actually at that time, because the price might actually change on the product after they ordered. For example, for Black Friday, it's different than when it is normally.
Yeah.
So you, like, getting in and figuring out how to model these things is really difficult. It turns out.
Well, I can imagine, because that's something that I've looked at it many times to try to understand this, and it's not an easy thing. It's not a straightforward.
No, but most of the time you will notice if it's wrong, because when you're querying it, it doesn't feel natural to go that way to query it. If that makes any sense. I don't have a whiteboard in here, so I can't really show what I mean. but you will notice if, for example, your many-to-many should have been a one-to-many. And you'll very quickly notice if it's a one-to-many that should have been a many-to-many. Because then you'll notice because you can't put data in your database. Many-to-many, that will technically always work. If you're in doubt, go that way. Because it's easier to go away from it.
Mm-hmm.
If it turns out that you were actually wrong.
Because it's many-to-many seems to be a lot more flexible than because you can, let's say,
Yes.
if you have a column that relates to a table that's not really used, you can pretty much remove that column.
Yeah. But the thing with many-to-many is that to define a many-to-many relationship, you need 3 tables, not 2, which you need for the other 2. But let's actually go in and look at how we actually define these things, because I think that will make it easier to understand. So assuming that we already have a student table, let's also create a class table. Create a table class.
It's really hard if there's no diagram.
Yeah, but I don't have anything to draw with.
Yeah.
Diagram. That's what I was doing
because
last
it's really
week.
better if you really
Yeah,
can. If
that's
you
what I
can
was
draw
doing
it.
last week.
It's
Like you
easier.
go in here and you start done.
Yeah. But again, let's go with an ID auto increment primary key, and let's just go with give it a location text, and it cannot be null. Let's just go with this for now and say this is how our class looks. We have an ID and it has a location.
Mm-hmm.
Great.
Don't you have to create a foreign key?
Well, let's not do that. Just get an understanding of how our data model looks.
Okay.
So what else could we have? We have. Let's go with.
Days of.
Let's just call it. Let's
days
call
of
it
the
mod.
week or something like that.
Module.
Modules,
So again, ID int auto increment primary key. Name, which is also text and not null. The modules would be like the database and the JavaScript modules.
Mm-hmm.
Right, so now we have these 3 tables over here. So student, module, and class. So now we want some relation between these things. So how would it make sense to model these things? So let's say, for example, a student would probably only be in one class. Exceptions for if they take a class again. But let's assume that that's not possible right now. So if we say that, well, a student is in a single class and only ever a single class, well, then we need to, probably it would make sense to have a reference to that class they're in, rather than having to call up the student and ask them, hey, which class are you in every time you need it, because they're going to be really tired of getting those calls in the middle of the night. So let's alter the table, add column, yes, class ID, which should be an int. I don't think we can specify foreign keys here. No.
I think you have to. I was looking into that.
Yeah, you can do it while you're creating the table directly, but we already have the table. So now we have a class ID here. But what we want to say is that a student cannot be in a class that doesn't exist, which kind of makes sense. Otherwise, they wouldn't really be students. So what if we want to do that again? We need to alter the table, student, and then I think it's called add foreign key, and then it says that student dot class ID. I think I have that. MySQL table add foreign key. It's not that often that I do this, I must admit. Add constraint. Yeah, so add constraint, and then we should give it a name because we need to be able to kind of remove it again if we want to. So we usually prefix it with foreign key fk. Student class ID foreign key. Well, which columns specify this foreign key? In this case, it's only the class ID, But if, say, we have a composite primary key, like a primary key with multiple columns, we can specify multiple columns here. And we say that these references class.id. I think that's basically the syntax. Won't like this. Error in your SQL syntax. So what did I mess up? Oh. Okay, that's fair. Class dot. So the ID column of class. Then, hey.
Can we slow down on this point, Rasmus, because you go very fast. Like.
Yes, but that's also because I kind of want to show you what happens when we do this. So now that we have this, and you can see the table didn't exactly change, but we now have a new foreign key that's called FK student class ID. So if we say now, all right, insert into student their name and their age and their class ID values. So that's how you spell your name, Val?
Yeah.
Let's. How old do you want to be?
25.
35 now.
What do you say?
35.
You said it's 25.
He's at 35.
He's at 35.
And then it's in he is in class 2. The thing is that class 2 doesn't exist yet. So if we try to do this, we'll actually be told that, heck no, you cannot do this because a foreign key constraint. Remember why we said alter table add constraint is failing. And it tells you here what it's trying to say is basically that the thing you're referring to does not exist. So if we select star from class, then there are no classes. Same thing if we select from student. Well, will not have been created as a student yet because the class ID we specified doesn't exist. So this basically allows us to add extra checks in the database that says that, nope, you're not allowed to do this thing because the thing you're referring to doesn't exist. And this is really where the name relational database comes from. It means relations in your data.
If the data can't relate to each other, then...
Yeah. So, I mean, and depending on who you ask, that they don't think that that's why. So, again, religious war. There's lots of those in programming for some reason.
Religious war in programming?
Like tabs versus spaces.
Oh.
That's called a religious war because people will never agree.
Tab versus spaces.
So basically, you connect you create like a new column, what's called class ID. And you connect it to the class ID, exactly.
Yes.
So it should be equals.
Yes, it says that whenever I try to insert something in student and I specify the class ID, it have to exist somewhere in the class table as the ID column. So you can use it to prevent bad data from going into your database.
Okay. Yeah.
But most of the time, because as you can see, this except error you get out here is completely like wacky. You can't tell your user that a foreign key failed when they try to register for a class that doesn't exist. So what you end up doing to give good error message is that you actually query for that class before, and then you tell them, nope, this class doesn't exist, and then it'll never violate. So that's why some newer systems like NoSQL databases, they don't have foreign keys. Because it turns out that the only time where you really use them is when you're messing around with the database manually like this. So
so the question here, like, if you want to make a relationship between two tablets, it has to be like they have share column.
Yeah.
It has to be.
Yeah, share one or more columns.
One or more.
Like, you don't have to create this relation. You can just remember that it's there. But it allows you to actually go down here and say, I think it tells me down here, that hey, this thing refers to this other thing. And you can also set up things like, well, what happens if the ID of the class changes? So you can say, well, on update, we can prevent anything from happening. Restrict, just say, you're not allowed to change that class ID because some other thing, a student, is referring to that. So don't do it. You have to remove all the students first. You can say no action, which basically means, all right, update it, but now you have some data that's wrong. You can say cascade, which is what most people will probably want, which is say, all right, whenever the ID of the class change, go back into the student table and update the class ID there. So rather than having to remember everything that refers to a class, you can have your database do it for you. Again, of course, at the expense of performance. Now remember why I told you that using IDs are really nice, because they will never change. That means you will never actually need to sacrifice performance for this. Because one thing is what happens if they change. Another thing is what happens if I delete the thing. So what happens if I delete the class and I have students referring to it? Well, if I say restrict, it will prevent me from doing that. It says that, nope, you cannot delete this database or this class because there's students in the class. So you're not allowed to do that, which is probably most what you want, so those students aren't left out in the cold. But you can also say, like, for example, I think if you specify as cascade, it'll just delete the students too. And that means if something refers to the students, and that's also cascading, that'll also be deleted. And then boom, suddenly you have no data in your database anymore. Which is probably not what you want.
Rasmus, once again, once you use cascade, the data and the students will be deleted?
So if I delete the class that the student is referring to and it's set to cascade, it'll say, well, I need to do something with these students because they're now invalid. And you did a delete, so I'm going to delete them too.
Okay.
If you did an update to the class, it'll just update the student to point to the new class ID. So if we had used the location of the class as the primary key instead, that might change, because like last time we were at the library, today we're here at Fynske Media. That would change all the time, and that would mean a lot of tables would be updating all the time. And you don't really want that for something that's just the location. So that would probably not be a good primary key. And reality, make your foreign keys refer to primary keys. Just makes your life easier.
Yeah.
You don't technically have to. As long as you specify an index on the target column, you can do it. Because the reason why it needs an index is that it says, all right, whenever it needs to insert a student, it actually needs to find that class. So that means if you have a billion classes and it doesn't have an index, well, it needs to go through every single one and check if it's that one.
Yeah.
And then only if it doesn't find it can it error out. But if it had an index, it can just say, I don't have this ID. Boom, error. Very fast. But if you're referring to the primary key, you get an index for free. So less things you need to worry about. So what kind of relation do you think this is? Is this a one-to-one, one-to-many, or a many-to-many?
Many to one.
Yep. Why?
Because many students to one class.
Exactly. So what do you think we would need to do if we wanted this to be an only one-to-one? Theoretically, if we want to say we can only have one student in each class.
Yeah.
So what we would basically do is make a foreign key the other direction.
One-to-one, you can put a teacher on each class. One teacher for one class.
Yeah, but then you also have Marco teaching it. And Krista. So that's why I tell you that basically you'll never use the one-to-one, because it turns out to very rarely be true. But yeah, that could be an example. Or you could have each individual lesson that has a specific teacher, for example. That could be a... But what you would then usually do is you would actually do both directions. But then you have the problem of, well, the teacher could be teaching multiple classes. And then there's suddenly a one-to-many. Again, and not a one-to-one. So it turns out that you basically never use that. because at least one of them will end up referring multiple instances of the other at some point.
So do you think it's better that we don't make this relation between tables? Just make each table alone?
Oh, I think you should definitely make the relation, that it makes it much easier. And for example, I have this tool here called Data Grip, which can actually read these relations and then help me write the code to query. I can just show you if it can load.
Why is everything in black?
Because I like black. Because I like sitting in a room that doesn't have light.
Nice.
And then it hurts if it's white all the time. MariaDB. Yeah, just download the drivers. Root. I think I set the password to this. Hey.
So now you can actually look at database.
Yes, so basically the database we were just in. So let's connect to the Hack Your Future thing. And say, let's just tell it that I want. Oh, and as you can see, okay, you totally can't see shit.
No.
As you can, let's just make it white.
Should I try to close the light?
No, because it'll just turn on again because there's a sensor here. That should be much clearer. As you can see, it just have all the tables that we just defined, and I can see all of this, but in a different way. But now, if I go say select star from student, then if I want to make a join, like we talked about last time, it can actually tell me here that, hey, you can join on class C on student, and it can write the entire join query for me. Because it can basically look into the database and figure out, well, how is your data structured? So even if I didn't create the database, I can still kind of investigate it and figure out how things work just because of the foreign keys. And there's a lot of programs that can look at this and then basically just generate code. So there's this thing called, what's the name? I can't remember, but it can hook into Postgres, and then it can basically generate you an entire API, including relations, just based on how you specified your foreign keys. So you don't really need to write any server code. You just write how is your data structured, and then you point it to your database, and boom, it creates everything for you. Which is, I mean, in my opinion, very nice. Though I prefer creating the server myself.
Hopefully we don't turn ourselves into code monkeys with all this automation going around.
Don't worry, you won't. Because it turns out what most of the automation generates is actually really bad. So.
And for you guys who don't know code monkeys, you know what that is? Code monkey is it's a derogatory term for a programmer who is just relegated to do tasks that are not important.
So if we need to look at the last relation, we have a many-to-many. So what could a many-to-many relation be? Well, it could be saying that a teacher could teach multiple classes, but a class can also have multiple teachers.
Yes.
So that could be an example. So let's create a teacher table. Teacher. It has an, guess what? ID. Key. It has a name. It's just not an alt text. So very, very, very simple table.
And you need class name.
No, because when we're doing if I specified a class name directly on the row, I could only have, a teacher could only teach one class. But we want the teacher to be able to teach multiple classes, and we want the classes to be able to have multiple teachers. For example, when we get to the React module, you will have someone other than me because I don't know React. And that's going to be Maria's pain to figure out how we're going to solve that. But so now that I have this extra table, so how do I connect them? So basically we say that each row in the database identifies one kind of data. So what if we just made a row that says that this teacher teaches this class? If we made a table that just tells us that, could that allow us to have multiple? Hint, yes. So we call it class teacher, for lack of better. And we just have the teacher ID, which is an int, and it references teacher ID. We have the class ID int, which references class ID. Now I don't need to specify the name of the foreign key here. And then I want a primary key for this thing. But remember how I said that there's one specific case where you don't make a custom ID column? So this is exactly that case. Because in this case, what uniquely identifies this column is
Both of them.
basically both of them. Because I can only teach the same class once, if that makes sense. Like, I cannot be here twice at the same time.
No.
I might be slightly psychotic, but not that much.
And here's coming question.
Yes.
What the difference between this relation that you make or creating this table, and then you can, why you don't make join?
Like, join is how we query the data. So let's just create this table.
Okay, let's see.
See, it succeeded. And we get another one called class teacher. So now if we go over here, for example, in a data grid that actually supports this, well, showing this, I can say select star from class joined with class teacher joined with teacher. So now I get a column for each teacher in each class, for each class, if that makes sense. So if we try to insert some data into a table, didn't I already insert something for this?
No, don't insert teacher.
No, I didn't. Okay.
Not even class.
So let's insert into class. Just have location. Values. Odense.
Yes.
And we also have one for Copenhagen. And then we can go, we need to insert into teacher the name. And let's just go with me. I'm not sure if Christopher teaches anything, but he will now. No, let's go with Marco. And let's go with Christopher Foden. Christopher. Hope I didn't butcher his name too much.
I think you can just hit, like, if
There's Will.
you're sitting on the line, you can just hit Control Enter. It will run the query.
Yeah, I'm not sure about this. I know that's how it works in DataCrypt, but I don't trust this program.
Try when you select that one. Just
So this.
one.
Yeah. Okay. Nice.
You don't even need to select it. Just the cursor is sitting on the line. Just hit Control Enter.
Nice. So now we have the classes and we have the teachers. So select star from teacher. Alright, I had really hoped for that to give me multiple results. It can't.
Really?
Only the last one.
Okay, let's go over to DataGrip with this because I really hate that. I cannot do that. So in this case, I will actually get multiple results. So you can see I have some classes, I have some teachers.
So you don't get them together, but you have two separate results.
Yeah, but it'll only be one network call. Usually your database is on another server. So now I have not told it how these things actually relate, right? So if I just do this, I get absolutely nothing. But what if I inserted some more into the, I can then actually say, all right, insert into class teacher. So I want the class and the teacher ID. I want the values. So select ID from teacher where name is basically Erasmus. And I really hope that this works. From class where location is equal to Odense. And that updated one row. So now if I query this one, we now have a result that has all of this. So it says that, well, the class ID is 1, the location is Odense, and the teacher is Rasmus. Okay, let's do the same thing for Marco. So you remember how I said that you can use these selects in other queries? This is basically an example of that. So that inserted 1. And let's go with Christopher and Copenhagen. Just execute all of it. That also did 1. So now if we execute this one, you see we get, for Odense we get both the teachers, and for Copenhagen we get 1 specifically. So this is a many-to-many. We could also say that, I'm not sure if...
Can we see the table down again?
Let me just do one quick thing. So let's say that Marco also teaches in Copenhagen. I doubt he does, but for the sake of example. So notice how we only have 2 rows of data in each table. We have 2 rows in teachers, and we have 2 rows in class. But we get 4 rows out here. That's because for each row it creates a row for each value that matches. And that's what happens when we do these many-to-many, because as the name says, we have many relations. Like for each of them there can be multiple in both directions. Yes?
The only
I think Val had a question.
Oh, sorry.
It looks like for me like when I make join, if I just add one call for the teacher and I specify the location of the class, and I make join between the class and the teacher on the location, this will give the same result?
No, because if I make a new column on the teacher that specifies the location, the teacher would only be able to teach 1 class. And what if we said that the teacher would be available in multiple classes? For example, Christoph might be available both here and in Copenhagen.
Then you have to have the teachers on one table and the locations on another table.
Yes, and that's basically what we're doing here.
So you can relate them
So the thing that you need to remember with relational database is that you cannot have a list of data. Like you cannot on some row have a list of other data.
Just one.
That's really what the problem comes back to here, and that's why we need that middle table called class teacher. Because that allows us to have a list of data for something. We need to query both of them for that data to make sense, but it does allow us to have that.
Okay.
And it will take a while to get your mind around.
Yeah.
But I would recommend now, when we talked about this, go and watch those videos, because after you have been thinking about what I said, and then you watch the videos, I think they'll be making a lot of sense.
Yeah, there's some. I saw some of those videos. I mean, the ones that I could see.
But the video is not accessible. I just watched one and they said like you cannot see the next one.
I was able to see some of them actually the first time. The second time I tried to see it, and they asked me to sign up and do a credit card.
And just for 1 month you have it.
Yeah.
In fact, I signed up and entered my credit card, but when I go back to Linda, it doesn't connect my LinkedIn to Linda. So when I open the videos in Linda, for one, it replaced, but in the second video it asked me to sign up, and then it routed me to LinkedIn. So I signed up, entered my credit card, and have a 1 month free. And then when I go back to Linda to sign in, the one that I signed up in LinkedIn, it routed me again to LinkedIn, and if I sign in, it does not reflect my my login information in Linda. So
there is something there. What you signed up for in LinkedIn is not Linda. What you signed up for is expensive version of LinkedIn, which is, I would recommend canceling that quite quickly.
Yeah. I already did. But it really asked me if I signed in or do anything in Linda. It really routed me again to LinkedIn.
We're working on finding some other videos, because like that was the documentation for this was written like 6 years ago. So some of this we can probably find something better that doesn't require you to sign up with a credit card.
Yeah.
Because that's really kind of stupid.
Yeah, I wish that there's something we can have it like in Slack or somewhere else where you can accessible like battery time. Maybe I want like 2 months I want to switch the game, for example.
Yeah. And I don't think that those Linda videos are the best either. To be honest. Like you can find a lot of shit on YouTube.
Yeah.
And honestly, I would recommend go there. There's probably some Indian guy who talks about all of this and can talk about a lot of.
Oh, I love those videos.
And for some reason, he's always from India.
It really.
But you need to write a code to understand what he's speaking.
You really have to focus. So, but then you kind of like when you start to understand what he's saying, you miss half of the video because you couldn't understand what he was saying in the beginning.
And in the middle of the video, you start to make.
It's not good. I have a book. I think I can bring it if someone want to borrow it, which goes into the theory behind all of this. It's really, really heavy and it's really easy to fall asleep with. Just don't recommend holding it over your head because it's about 1,200 pages.
Oh.
A4, so it hurts if you drop it.
Is it PDF or?
I actually think I have it on PDF. I should probably not show that on the live recording.
Yeah.
Because it's one of those PDFs.
Okay.
Rasmus, do you have a certificate for DB?
The what?
Do you have a certificate for database?
No.
No.
I don't have a certificate for anything. Like most of the time you don't need certificates. They are just a really, really easy way of getting around all that. Do you actually know what a database is? Yes, Amazon tells me I do, so basically.
Yeah, we're on a era of cheesy certificates. You can get them online very easy.
Yeah, there are actually certificates from Amazon or Microsoft and so on, and they can be good to take because they allow you at least to get around that part of the interview.
Yeah.
And some companies they just require them. So.
Yeah.
But it's very rare, especially in Denmark.
I find it here in Denmark it's like people require. I mean, I was talking to somebody. Sometimes you see like they require a lot of studies and you have to have a master of this and a master of that and this. But in my mind,
it's basically bullshit.
Yeah, that's because it does not relate actually because you have a PhD on rocket science. It does not relate that you're a good scientist. You can be very lazy.
Let's get back to this. Just for now, especially because I am recording. So we also kind of talked a bit about these rules and this referential integrity. While having a very fancy name, it basically just means that if you tell it to point at something, it will not allow that thing it's pointing at to not be there. It will not allow you to insert something that points to something that exists. It will not allow you to remove something that's being pointed to, unless you do these things where you set it to null, for example, when it's removed. So that's basically referential integrity, making sure that what you're pointing to actually exists, which is really one of the really, really strong part about relational databases. Mm-hmm. We also kind of looked a bit on how to defining table relations. We saw this way of doing it, which is the really long way of adding it to an existing table, but we also looked at how to do it inline when we create table directly. We can just say column name references some other table. And then the last two parts they have here are NoSQL databases. We will not be talking about that because that would probably require something like Mongo, and for some reason Hack Your Future doesn't have any documentation about that whatsoever. So I'm not sure what we would be talking about. But it's basically another way of doing things where you don't need to specify anything ahead of time. You just make chaos and then you hope for the best. If you couldn't guess, I don't like NoSQL databases.
They say NoSQL database is just because it doesn't use the SQL language, but it uses another language for it.
Yes, and a lot of them is also what we call document databases, which means you just stuff JSON in them and then they store the JSON for you. But then you kind of need to make all that validation that your relational database can do, you need to make sure to do in your application layer. Because otherwise you will suddenly point at something that doesn't exist. Or when you delete something, you will not update the other documents that point to it, and you need to validate all of this yourself, rather than just having the database tell you what you're doing here is going to blow your data up. so don't do it. But it allows you a lot of flexibility if you don't know, well, how is my data actually looking? If you don't know really what your domain is yet, it can be very useful to use a NoSQL database because you don't need to care about how your domain looks. But that also means that you can get documents that doesn't have the same columns, which means that when you pull out the name, like the document created 2 years ago might call it name, the document created now might have 2 separate columns called first name and last name, and you need to figure out what the heck you're doing, which a normal SQL database will prevent from happening.
That sounds kind of messy.
What they're really good for is what we call non-structured data. When you get, for example, analytics data, shove it in a NoSQL database, because NoSQL databases, they're really, really good at spreading data across many machines. When you get analytics data, you get a lot of data. So it can be a good idea to do. Some of them are also kind of the guarantees they make that the data will be saved. Not always that good. MongoDB, which is one of the more famous NoSQL databases, had a little problem where they told you they saved the data, but they didn't. And then if you turned the database off too quickly, you lost your data. Oops. So now I shipped the thing to the customer, but I didn't actually remember to write down that I shipped it to them. Yes. So if you want to do, there's a lot of courses on these things. They will make more sense once we get into Node, where we're actually just working with JavaScript objects and we can just stuff in the database without thinking much about it. It can be a really fantastic property. If you're working in a more structured language like C# or Java, it gets more iffy working with a NoSQL database. Like at that point, you have abstractions that makes working with a NoSQL database practically the same as working with a normal SQL database. And like at that point, I would choose the SQL database. And then you also have like a lot of databases nowadays are allowing you to define a column as JSON. So you can actually use your normal SQL database, have all your strong guarantees, but actually working without the strongly typed schema, so you can still just stuff shit in there and hope that things works out. Yeah. I mentioned I'm not a fan of NoSQL databases, but there are reasons for them. And then there's this thing called GraphQL, which is, it's like GraphQL is a fantastic thing. I love it.
Just don't use it.
No, like seriously, use it if you can. But yes, there's this. Like everybody knows Pokemon, I assume. Just to try it. If it's not dead, at least. It's also this one. Yes, so there's basically, GraphQL is this, we have worked with these just fetch, where we just get a bunch of data back, and then we hope that that's the data we need. What GraphQL allows us to do is define what we want back. So we can say that for the Pokemon that has a name of Pikachu, I want the ID, I want the number of it, you can see they are out here. I want the name, their attacks, their specials, and their evolutions. And for that, I want all this data, blah, 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 blah. And basically, if you say, I don't want the name disappears from the output. And then the whole graph name comes from the thing that they allow you to go around following these things as what is called a graph. What does it look like this? All right, so that's
That
just
looks like a JSON object.
Yeah, it basically is, kinda. But then again, not really. All right, so this is not the best graph API. We all know GitHub. They have a GraphQL API. It's actually really good. Explorer. Yes. Sign in. Blah, 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 blah. Authorized, some very long password. And then what we get here is basically, I can, alright, give me who I am. So I'm this guy called Slipper. That's fine. I want all the repositories that guy have, and I want basically the first 20 of them. For each repository, I want its nodes, and then I want the name of the repository. I want to know what can we take from it. I want to know the, what is this thing called? So you see, there's a lot of things we can get on GitHub. If you were ever in doubt, collaborators, and for all of those, I want their name, or rather their login. And then it gives me, well, for each of them, there's the repositories, who collaborated on it. So you see, for example, there's multiple here. And then it gets mad over that I'm not allowed to read some of it.
How do you use it? Where do you use it?
So you can use it, for example, if you're a front-end, you're making a front-end application, JavaScript. You could specify that for this view, I know I need to list the following 4 things. I don't want anything else. Then you specify only that. And then that's basically it. But because this is a graph, this allows you to search what we call a graph. So for each of these collaborators, I want to get the name of the first 10 repositories for them. So you can see again we have this slipper guy who has a couple of repositories and so on. So it allows you as a front-end developer to really only get what you want. So usually when you have, for example, a page like this, to load this page we do about 20 network requests. Just getting different kinds of data we want to show. We make a network request to figure out who the heck is the user. That takes 4 requests alone, which is this many. Not this many. Then we need to figure out, so what folders are available, what collections are available, what status is down here, which files are here, what about all this over here, and a bunch of other shit going on in the background, like what's the settings of this current application. And we need to do 1 request for each of those things. And like A, that's a really annoying amount of code to have to write. B, I probably get more data than I actually need. Like for example, I get, what's something that we don't use here? I get a URL I can use to actually download the original file for this, not just the cropped preview we have up here. I get the original, but I'm not using it here. So that's a waste of data to send to me because I'm not using it, but that's just what the API gives me. So GraphQL allows me to specify that A, I want all of these many things at the same time. If you go back into the GitHub Explorer.
I think my question is like, what is the engine that reads it? How do you implement the code? Is that code mixed? Is
So
that like separate files like JavaScript stuff?
We are going to be looking at that in the end of the Node.js module, how to actually implement the server side of this, because it's quite advanced. But Facebook have this library called GraphQL, which is basically the official implementation. So you write what's called a schema, you write something called resolver functions, and then you make it all happen. A ta-da. But then you also need to load the data from somewhere, and it becomes more advanced. But it's a bit more work for you on the server side, with the benefit that you don't really have to care about what the client needs, because they can just request whatever the fuck they want.
Okay.
But the benefit is that you make it really easy for your client to work with, because they can get, and like they have this Explorer thing, they can just type out, ooh, so what can I get here? I want this repository who had this strange guy who owns that, and that should be what's one that I know exists? That one. So for that one specifically, I want to know how many stars. I want to know exactly who actually stars it. Login. then I basically get both of those things back, and I could not get that. I think there's some permission issues with this being an Explorer node. But I can really just explore the API and figure out, well, what first 10. Yes, so then I get some back. But allows me to explore and figure out what can this API do without having to read a lot of docs, assuming someone wrote those in the first place, which can be a challenge. Developers hate writing documentation. Most of them do, at least. So here, all of this is basically just auto-generated based on what you specified on the server.
So it seems like this is what actually happens when you fetch an API in JavaScript.
Well,
more or less.
Usually that API just says, I return specifically this.
Right.
And only this. If you request me, you'll get this back whether you need it or not.
Okay.
Which means sometimes you send too much data, sometimes you send too little. Which is like that. About sending too little is the problem we have here. We need to do a lot of requests to get all the data we want to show the entire application. And that's why we have this really, really long load spin in the first place. Because we need to do a lot of requests. So that's the basic gist of why it's beneficial. But I mean, for most things, you can get away with what we call a REST API, which we will be going into in the node module. Which is a lot easier to write, and what most people expect. Because writing a GraphQL API is kind of difficult. Because you need to be able to do things that can follow these. So when I get to collaborators, I actually get back to some users again, and then for those users I can go out and dig into what they do, and which is something we call graph theory. But that's a bit more difficult to do. But there's a library that handles most of the heavy lifting. Then you just need to do the actual. It tells you, I need to get the user and I need to get these 3 things on it. And then you figure out how to make that happen in your database. And then there's systems that can just hook into your database and generate all of this based on foreign keys and such. So, is there any questions for this GraphQL or for any other things we've talked about today? I assume foreign keys are still kinda they take a bit to understand, and I personally think they took a lot for me to understand how to use and when to use. But as you start modeling up some proper data, you will start to notice why they are smart, and it happens almost naturally that when you create the table, you say that this thing has a reference to this thing over there. Then you get into the many-to-many tables, which are kind of need to remember how to model them. But so any questions?
Just about this GraphQL.
Mm-hmm.
It's just like the way how you make the request is instead that if you ask for the whole page of API, you just specify what you want exactly from that.
Yep. So
That's it.
Yeah, that's really what I specified here. For the current active viewer, I want their login. But I could also say that, but I also want, let's not go with that. I can also specify that I want to get their name back, and then I get both the login and the name.
So just like I want to make it simple for me myself. It's same when I want to enter text for when I make a request for API, I get all the information as a JSON. Mm-hmm. And from that, I want to specify after I read the data, I just want the name and put that in the text.
Yes.
That's what you're doing here.
Yes.
Instead of if I get all the data, I request a part of the data.
Yeah. So, because funnily enough, getting less data is faster over the internet.
That's what I wanted to.
Surprise, right there. So that's what this is about, getting less data, and also in other cases getting more data. Because what if that, imagine if I had to do this manually, the request we see up here. So if you just turn around. Yeah. So if I wanted to get the viewer, that's probably on something like /API/viewer. That'll get me the login, the name, the URL to my site, and a whole other bunch of shit that we probably don't care about because we only wanted login and name. But then if I need to figure out what the repositories, then I suddenly have to go out and say, all right, /API/viewer/repositories. But for those I want the collaborators, so then I need to go, for each of those repositories, I need to send a request that says /API/repository/the ID of the repository/collaborators. And then for those, I actually want some more specific data, so then I need to go in the /API/user/the user ID/ whatever the fuck. 200 billion requests later, my site has still not loaded and my user has left to something that's fast.
Yeah.
So that's the idea of this, because the server is closer to your database, it's faster to have that request the data. And it basically comes back to what we call latency. So there's two things that limits how fast you load things: your download speed, and what we sometimes is called the ping time. You know, when you do a speed test, you get a ping. That's basically how long time does it take for the data to go to the server and back.
Yeah. And how many hops between that also is counted.
Yeah, no, that usually makes it slower. But the speed itself doesn't actually say anything about how many hops you have.
Yeah.
But depending on what's the limit, are we limited by how fast we can get a reply back? Or are we limited by the size of the reply? There's this shitty internet. There's this saying that a Volkswagen rolling down the highway with hard disks inside is actually pretty. Like, that has a pretty big bandwidth. Yeah. Like, when that arrives, you'll have probably a petabyte of data in one go. But it'll take 2 hours before you get the first byte. But you'll also have the last byte right away. So that you have a huge bandwidth. You can send a lot of data in one go. It just takes very, very long time for it to arrive.
Yeah.
Whereas, like, I can go directly and request something from my database, but the speed to that database might be very little, but it can give me a reply pretty quickly. And that's basically the same thing here. So we're figuring out all the different net requests that needs to be done. We're basically moving that to the server, because the server might be this close to the database. Whereas you're sitting here, and then the server is in Germany. That takes longer than the database just need to traveling over this much wire. So that's basically why this is, and actually ends up being faster, even though it's basically doing the same amount of requests behind the scenes. Then you can do all sorts of optimizations, because you know that, I only need the name and the login. So I actually rather than just doing select star, I just select name, login. And then I only get that out of the database, and that's again faster than getting all of it. So you're kind of optimizing the whole way, but it also takes a bit more work than just saying select star, get into a JavaScript object, send that back as JSON. So it's kind of a trade-off in who are you helping. Are you helping your front-end or your back-end developer, essentially?
But normally when you make the API request, you write the link for that one.
Yeah.
And how you should write this one?
So what happens here is that there's basically an endpoint called /GraphQL, which takes a body of this, in which you literally just send this entire thing to the server, and then it figures out what to give you back, and then it returns it to you as JSON. So you end up only having one URL where you just send data to, and that then returns data to you based on what you send it. So it's kind of a different way of working. The downside of GraphQL is that it's really, really difficult to cache. I cannot pre-calculate it, because I don't know what my user requests. If I know that my endpoint will only ever return this, I can just put that in RAM and keep it there. And then I can return it right away. I could even cache it on the user's machine if I were so inclined. It's kind of difficult if the user can just request whatever data they want and however it looks.
Yeah, it's more advanced, it's more harder to become.
So you're trading off flexibility for difficulty and complexity, which is almost always a trade-off you have. Like, the easiest system you could imagine is something where the front end can just go directly to the database. That works very well until your front end says delete from table, semicolon. Then you have no more data, because there's no where.
Yeah.
So it's always about doing a trade-off between these things. And GraphQL is what many people call a reasonable trade-off, because it makes it easier to develop really fast in the front ends. And you can actually also kind of speed up your backend development a lot, because you only really need to worry about like one layer of the graph at a time. You don't really need to worry about what data do you need You don't need to figure out and actually talk to people, which we like because we don't like talking to people. So you just need to figure out, well, what data can I give them? Then they can request it if they want it.
Yeah.
But we'll
To know what data I can give them, it's like the normal API request. And what the data they want is this one.
yes.
Okay. Yeah.
But I think once we get to the node module, we'll actually try to set this up because we actually have another week available now.
Yeah.
Because we kind of just finished 2 weeks in one, and it's not even 7 o'clock yet. So yeah.
So we're done today?
Kinda. I just want to talk about that, what we're going to be doing next time.
Mm-hmm.
And also because there's some homework for some of this. So for lesson 2, which is you basically need to write just more SQL queries, as you did for the last one. So that's relatively doable. And then for this one, you actually need to write a full-on application that talks to the database. But we don't know how to write Node.js yet. So this is going to be a bit difficult. So we'll be moving this homework to some time later when I think it makes sense. I'll also be writing out all of this on Slack, so you will have it. And then Marie can yell at me, not you, for changing the curriculum.
Yeah.
Just close your phone.
What?
Close your phone.
It's a little too late for that.
I mean, the thing is, if you don't have me teach, there's no one available to teach, so she doesn't have a choice.
Yeah. I should deal with him.
So next time around, we're going to be starting out the Node.js module. The first thing we're going to be doing is actually installing Node so you can run code on your machine without actually running it in a browser. I saw that some of you had it installed already.
I have it
It's
installed.
visual.
No, it's just
Node.
like Node.js. It's basically this thing. It's pretty easy. You just like download it and run the installer. So not the most advanced thing in the world. We just want to verify that everything has it ready, or that everybody has it working. And then there should be a Node course here, right on the top. So it's basically 5 weeks where we'll be going over basic Node, HTTP, how to actually do APIs, and how to talk to our database. Because as you can also see here, the Node module also kind of depends on the database module. But the database module depends on the Node module. Like, who the fuck organized this?
Yeah. You should make a relation between these two tables.
Yeah, except one hard depends on the other existing, so you can never create something.
No.
But that's what we're going to be doing next time. I would recommend doing the database week 2 homework, just so you have it done. And that's also what they're going to be checking for you, the other mentors. And then we'll be doing JavaScript next time. Again.
You said last time, because I submitted a homework for week 1.
No one checked it?
No, I put it on Slack and then I just said, okay, I don't know because I remember you saying it's like just created like a text file.
Yeah.
I mean, I put it on you can actually save once you run it and because you just save the query and it saves a SQL, which is a file, which is basically a text file. And
oh yeah, so you put it here?
yeah, and I also uploaded to GitHub later.
Okay, so I'll talk with some of the people who check the homework, make sure it gets checked.
Yeah.
We're done today?
Yep.